Hello, welcome back to Cracking the Cryptic, a special Patreon episode. And this is occurring because Simon dropped me in it yesterday without consulting me live on air. He decided that I would be having a go at the example puzzle of Phistomeffel's Lighthouse. Now, so we can understand the rules. Phistomefel provided this. He told us that although pretty tricky, it introduces some of the concepts that are used in the larger 9x9 puzzle, which Simon is going to live stream tomorrow at 9 o'clock our time on the channel, so an hour earlier than the live stream computer games have been going out. Simon is going to have a look at, well, I say he's going to solve it, he's certainly going to attempt the 9x9 lighthouse. Now, we've had a lot of correspondence. A lot of it has said that that puzzle is very difficult. Quite a lot of it has said that this puzzle is difficult. So even for a 6x6 grid, apparently this is pretty hard. But we'll see how we get on. We'll see if we learn anything. We'll see if Simon watches this before he tries his puzzle and learns anything. I get to solve a Phistomefel. I'm not sure that's ever happened, actually. Certainly not live. I mean, I've solved a number of them myself. Anyway. You get to watch me solving a Phistomefel, and that is a pleasure for you. No, it's a pleasure for me. Let's see how this goes. Let's read the rules. So, because we're not in a 9x9, we have 1 to 6, not normal Sudoku rules. 1 to 6 must be placed in each row, column, and region. But the regions, each 6 cells orthogonally connected, so that could be a region, need to be determined. So we're going to have to find them and colour them, I presume. A digit in a circle indicates the number of borders between regions it sees in its row and column. So, note that the edge of the grid doesn't count towards this total, and not all circles are necessarily shown. Why would they be? Right, so let's look at this 5. What that means is that in this row and this column, there are 5 boundaries between regions. So, I'm going to just create a possible. It would be great if this turns out to be right, but look, if the regions were like this, let's see if I can make one which has 5 boundaries between the regions. So orange was a stupid color to use next to red. Let's go purple there. Then we could have blue. I'm going to fail here. That's quite interesting. There are clearly limitations. So let's put the purple cell down there, yellow down there. We can have blue here, dark grey, and green. Now I reckon I've done this so that this would work, so that there are 5 boundaries that this cell sees in its row and column. So one of those is between red and blue, and second is between blue and grey, a third is between grey and green, a fourth is between red and purple, and a fifth is between purple and yellow. So that would work for the 5. It clearly doesn't work for the 1. So that is the rule, though. That's what these circles, we only get 4 of them in our 6x6 grid. I think Simon gets more in his. That's what those circles are telling us. And apparently that and these 5 given digits are enough to determine this region. So do try it, providing a link below the grid in the description field of this video. Do give it a go and see how you get on if you want, but I'm going to start now. Let's get cracking. I think this 1, the reason I didn't show an example grid for the 1 is I think the 1 is helpful. The 1 is saying that only 1 region boundary occurs in these cells. Okay, so in either the row or the column, there is no region boundary. And that means it's a straight line 6-cell region. But it's either column 1 or row 1. Now in the other, let's assume it was column 1. In the other 5 cells, there'd be no boundaries too. So these 11 cells, I'm going to make them purple. Those 11 cells are part of 2 6-cell regions. So there's 1 more cell to add. And there's either a region boundary here. Oh, I could use the pen tool, couldn't I? if you click on the cog, you can enable the pen tool, and then you can click on that, and I think, yeah, look, I can do these X's if I want. So one of those X's is a region boundary and is the only one in row 1 or in its row or column, and the other one doesn't have any. So this 5, let's just get rid of that for now. This 5 is seeing either 0 or 1 region boundary in its row. Well, it would be very difficult to see 0 in its row. If it was seeing 0 in its row, then it would see 5 region boundaries in its column. All of these would be region boundaries. Wouldn't they? They would. And then that would mean there was a region starting here and another region starting here, and another one starting here, and another one starting here, and another one starting here. Now, you're wondering, maybe, could those regions not be the same? Couldn't they overlap? But they can't, because even though you could make that all orange and you'd have a 6-cell orange region, you'd have killed off the green region. So that wouldn't make any sense. So they would all have to be different, and this can't be, because that's 5 different regions. We're only looking for 6 regions, and purple is going to supply 2, so we'd be up to 7 regions. So that is not what is happening. We do not use 5. This must be right. I think this is right. This is a weird rule set, to be fair. We're not using 5 region boundaries in column 6. And therefore we're using 4 and 1 in row 1. So that is a region boundary, and now I can change the colour. This is no longer purple, it's now green. So green is a 6-cell region which has 2, 3, 4, 5 and 6 in row 1 and a green 1 somewhere in row 2. This can't be the 1 because there are definitely 4 region boundaries in column 6. There are none in column 1, we know that, but there are 4 in column 6. So this is not the 1, so that's not green. Let's give it another colour, orange. That's about all I know so far, but it's a start. I wonder if Simon's will start. I bet he doesn't get a 1 in a circle anyway. Now, what do we need to think about next? Okay, this number. We've deduced that there are 4 region boundaries in column 6. So that is either a 4 or a 6. And it can't be a 4 because there is clearly, yes, I could have marked all these as region boundaries using the pen tool. They are all region boundaries, so every row has at least 1, including row 2. So this is going to have to be a 6. Oh, what have I done? I put a circle in. Oh, go away. Right, there we go. So this is a 6. Is that not working? Oh no, I'm not on the cell. Right, that's a 6. There are 2 region boundaries here. Ah, and we know the green cell comes into this row. Yes. The green cell comes into this row, so the 2 region boundaries are orange to green and green to purple. We can't have any others. Green to purple has to be here. Ah, I'm getting on well here. So green there. Obviously, these are all region boundaries. I might as well mark every one, because that will help me count them. Now that means the rest of these cells here are all orange because we can't have another boundary for that 6. Right. Now I still know there are 3 more region boundaries between these, in these 4 possible places, but I don't know where they are. I've used that 1. Knowing that is all that 5 and 6 are left to give me. Oh, I know this is a 1 because that's where the 1 has to be in green now. And it's this cell. This circle is going to give me the rest of the puzzle somehow. I mean, how? How is it? Okay, it's 2, 3, 4, or 6. By elimination. Thank God I'm not doing a 9 by 9 puzzle, or that would be good lifting to the max. And it's seeing 1 region boundary in row 1. So it's clearly not seeing only 1 in column 3, because orange can't get down to the bottom. So that's not a 2. How could it be a 3? If it was a 3, orange might come down to there. Yeah, I suppose this could be another region below orange. That would work for a 3. I'm just going to pencil mark these cells. I can't believe the Sudokuing is going to help much in this puzzle. Oh, okay. We do need an orange 1 somewhere that can't be here. I don't know. Well, it could be anywhere in those cells at the moment, as far as I can see. Actually, it couldn't be there because of the number of borders in column 6, but that's not useful. I really need to get something going. Oh no, okay. Okay, my theory earlier was interesting, wasn't it? That we ran out of the number of colours in column 6. Well, that's still the case, right? We are still going to have 3 more coloured regions down here, and they're going to be the last 3 colour regions. We're only having 6 regions that are coloured. Orange can't go all the way down, and in fact it can't go down to here. So this one could be orange, or this could be a region boundary, and this could be the next colour. So let's make the next colour in column 6 blue. That's orange or blue. Then this one is blue or the next colour. This same principle still applies, that it can't loop around and cover a 6-cell region, so that's fine. Then this one can be yellow or red, and this last one must be the 6th colour. So that's red, and I'm counting 6th as purple is 1, green is 2, orange is 3, blue is 4, yellow is 5, red is 6. Now I don't know which one of those, orange, blue, yellow or red, occupies 2 cells in this column, but one of them does, and the others all occupy 1. But the trouble is, what the heck does that tell me? Okay, well this couldn't be any colour other than red. Orange can't reach it, that's straightforward. Blue and yellow could reach it, but only by bounding too small a red area. You couldn't get a red 6-cell area coming out through here and then blue or yellow snaking around to get to here. So that's red. I have a feeling you could extend that quite a lot further, but mate, what, this cell I'm in, can that be anything other than red? I don't know if this is really helping me. If I could get to there, maybe I'm getting some idea. Like, I'm prepared to bet this is a 6, but I need to prove it. Oh, I don't know, actually. That 3 was quite a useful orange and... no, this can't be a shape. Yes. We've only got orange, blue, yellow and red to complete. So that can't be a shape because it doesn't reach orange, blue, yellow or red. Well, this cell, how is that going to... This cell, okay, right, I've got it now. Well, I've got something. Every cell in this grid, every white cell that we have left, has to reach the right-hand perimeter, doesn't it? It does, because it's either orange, blue, yellow or red. Each colour has to appear on the perimeter. So this cell can be orange. And that's an easy way for it to reach the perimeter. If it's not, well, it can't be red because it can't get to that cell in only 6. It could just be yellow. Oh, well, it would be yellow, something like that, bounding orange as a 6-cell region. Oh, I thought this was going to be more helpful. But we've got something like bands of colour going on. I don't know exactly how. Yeah, there's some sort of... It's not exactly orange along there, obviously, because that would be 11 cells of orange, blue along there, yellow along there, red along there, but it's something getting towards that. I'm still, I have to say, just thinking about the numbers, how are we ever going to fill the numbers in? I don't understand that at all. I can just about see we might be able to determine the shapes because there may be only one version that fits. But how are we going to do the numbers? Maybe this circle is more important. What is it? Oh, yes. Why can't it be 3? Yes. These 4 can't be in the same shape, obviously, because they could never then extend as far as the right-hand perimeter. And indeed, 3 of them can never be in the same shape. So you could have 2 and 2, but yeah, I'm not really interested in the number of colours that appear in column 2, but I am really interested in the number of colours that appear in column 3. Now, according to this, the number of colours that appear in column 3, there's one border in row 1, and there's either 2, 3, or 4 borders in column 3. And that means that there are colour changes 2, 3, or 4 times, but that means the number of colours or new colours is 3, 4, or 6 colours. Because I'm adding 1 to the 2, 3, and 5 that are the number of borders in this column. I don't know if you're following that, but then maybe I should depict that. So if that was blue and that was yellow and that was red, then the count here would be 1 border, 2 borders, 3 borders, 4 borders, and the one we had up here, hang on, what? Let me actually print them so I'm making sure I get the count right. So the count of borders in this column would be 4, and there'd be 1 in row 1, and that would have to be a 5, which it can't be. So this can't be right, interestingly. So there are not... Blue, yellow, and red don't all appear here. Oh, and it just... Okay, I was going to say that we... Oh, sorry, I don't know what I'm doing with this pen tool sometimes. Let's go back to normal. Right, let's get rid of those. Now, does that mean that blue, yellow, and red don't appear here? Yes, sorry, what I was going to now remark was there is a chance of sort of overlapping shapes, like one there, let's just make it grey, and one there. And this would give us lots of region boundaries and not so many shapes. But I think in this puzzle we can discount that because you just can't have looping around. Remember, every shape has to reach the right-hand perimeter. So, yeah, I think this is proving that we're not going to get all the colours in this column. And that can't therefore be... For this to be a 6, we would need 5 changes down here. Green to orange, orange to blue, blue to yellow, yellow to red, but one other change fitted in as well. So that would require some looping colour, and there's no room for that to occur. Not at this distance. Like if you were allowed a 7-cell cage, you could reach the right and loop, but yeah, I don't think we can do it in this grid. It doesn't fit. So I don't think this can be a 6. I was betting it was a 6. I don't think it can be a 6. But I also don't think it can be a 3. Because the furthest orange can get is down there. And then we worked out the shape that would get bounded, given that those two are in the same colour, is like that. But that doesn't reach the right-hand side. Orange might... You can't put those 4 together and still reach the right-hand side. And even if you put 3 together, and look, you could reach the right-hand side there in red, but that cell would have to be orange, and you'd get cells bounded in here that couldn't form part of a 6-cell shape. So I'm pretty sure, I want to be totally sure, but at the moment I'm pretty sure that there's no way this can be a 3. There might be a way to actually prove this. But if there isn't a way to prove it, I am going to rely on saying there is no shape that fits in here. Maybe the thing to do is to consider, how do these cells reach the right-hand side? So this one can't be orange because it can't reach that within 6 cells. But it does reach the right-hand side. And to reach the right-hand side, it's going to use 4 other cells, at least. But it can kink by 1. Well, it can't do that. Okay, it cannot use those. Okay, this cell is interesting. Let's colour this dark grey again. How is that going to become blue, yellow, or red on the right? If it was to use all those 5 cells, well, then you've got an 11-cell, no, what's that? A 9-cell region in rows 2 and 3, one of which could be dark grey, 6 of which can be orange, but nothing else. You know, the others would have to be another colour, and they wouldn't ever get out and make a 6-cell region. So this does not go across like that. Therefore, it does kink somewhere there. Well, it can't kink there, or it will cut off a cell. It could kink there. That looks rather nice because orange would work. So we'll store that one up. If we did that, that's no good. There'd be too many orange cells. If it did that, again, a problem with orange. The same is true if we use those 5 cells and go down. Certainly we're getting too many orange now. Can we kink down? Oh, that would work, because then red would be below it. But if you do that, there's too many red cells. If you do that, there's too many red cells. If you do that, yeah, that doesn't work as well. So we've got 2 possibilities for this grey cell. It's either there and is blue, or it's there and is yellow, which I had hoped. So that is the same. It either kinks up there or down there. Now, if it kinks up there, we get orange here. Yellow, well, I don't know, yellow and red are quite hard to determine here. So I need to think about this more, don't I? Ah, if this kinked, no, it's not there. If it kinked up here, we'd get too many borders here. We'd get a green bordering orange, orange bordering blue. Oh, okay, this is possible. But then these two cells would have to be in the same colour. The two cells below in column 3. They'd have to be the same colour because this can't be more than a 4. And if they're the same colour, they're bounding in two cells beside them on the left. They're going to have to be the same colour. That's 4 cells. So this, let me just try and show you the regions I'm talking about. I'm just going to get rid of the colouring here. Well, in both of these cells, let's get rid of that. And I'm saying that if that was one region, then you've got a border between that cell and that cell. You've got a border between that cell and that cell. These two would have become orange. And then these two have to be all one region so that we only have 3 borders in column 3. If they're one region, they go with those two, which they're cutting off, and now they can't reach the right-hand side. So that's not what's happening. So we go back to this position. This must kink down here, and it's therefore yellow. So this group of cells is yellow, and in fact is a region, and we have probably finished the shading of the colouring of the puzzle. I'm not certain about that. This is no longer yellow, so that's blue. Don't know about that yet. I know where red is now. Red is all there. And this is right. This is the right answer. This is gonna... yes, this tells me what happens to orange. It's got to go here, because otherwise this is gonna not be... This is already at least 4, so we'll put the 4 in. We've got the region borders. Let's mark all our region borders around the yellow shape. I am not, by the way, prescribing how Simon should use the pen tool or that he should use it at all, but this helps me visualize it. I'm not quite so good with these pencil puzzles style as he is. But look, we've now got the 3 X's in this column, the 1 in its row. So that 4 is fulfilled. So this cannot be a blue. It can't be blue, or they'd create a different X. So that's orange. It cuts off this shape, which is orange. Everything else becomes blue. We get a little blue rectangle. Let's finish off the region borders because there aren't many left to mark. And we like a bit of completism on the channel. So those are blue. And there is the colouring. We are done with the colouring. Now we just have to do the Sudoku bit, which I am frankly doubting can complete. I mean, I know it does apparently. How do we do this? So we've got 2, 3, and 6 in the top somewhere. I'm just going to disable the pen tool because I don't need it anymore. There we go. I didn't delete the borders I have marked. 6. Oh, we've used that. So 6 in this row is in one of these 2 cells. 5 in blue is in one of those 2. Yes, okay, now I see that we are going to complete it, because what I keep forgetting is that all the colours act like killer cages now. They must all have 1 of each number in. So 6 in yellow is in one of those 2 places. 1 in orange, we can get that because this one sees all the other available cells. Then 1 in blue is in one of those cells in row 4. 1 in yellow now can't be, oh well, it couldn't have been in any of those anyway. It's in one of those 2. 1 in red is somewhere along there. That's actually not as helpful. That can't be a 2. Do we know what this is? This is the same as that. Yes, that's interesting. Because the red shape uses those cells, the bottom row uses those cells. They're equally a set of 1 to 6. So if you eliminate those 5, you're left with that in one case and that in the other. So they must be the same. So that can't be a 2 now. It has to be 3 or 4. That can't be a 2. We now know where 2 is in column 1. This is a 3, 4, 5 set. And therefore in orange we know where 2 is. This is a 3, 4, 6 set. This is a 1, 5, 2 set. This one can't be 2 and this one can't be 5, but that means this is a 3-4 pair. We can fill them in thanks to this 4 up here. That enables us to sort out all these 3s and 4s. This is a naked single. Look at that. 4, 3, 2 in the row, 5, 6 in the column. So that's a 1. Let's get rid of the corner marking. I think we're going to tidy up this box now. We get a 2 there. Okay, I am going to get rid of the corner marking again because it's just distracting me now. No, we're not going to tidy up the whole blue box as I thought. So that can't be a 1. 2 is in one of... Oh look, that 3 has sorted out column 3. 5 there, 6 there, 2 there, 5 there, 1 there, 5 there. These both can't be 5s anymore. That is now a 6. Right, so green is finished. Orange is finished. If I could type correctly. Don't want a bout of Simonitis going on today. Look at that. Okay, so we've just got 4 columns to finish off. 5, 1, 6, 4. Okay, so the checker is reporting that I have completed the puzzle correctly. Let's bear in mind that it is not checking these regions because I don't think it recognizes the colors. So it doesn't know, it certainly doesn't know if I've obeyed these circle rules. It also doesn't know if within orange I've got 6 different digits. It does look like I have got 6 different digits in each color. So that must be the solution. Very symmetrical around the middle axis, mirror symmetrical around the division of the grid between rows 3 and 4 in terms of the colors, the shapes. Now, I'm quite interested to know whether all circles were shown. So could Phistomefel have circled any other colors? Let's just see if we can find one he could have circled. Not that 3. 1, 2, no. In the yes, that 2 could have been circled because it sees 2 boundaries in its row and none in its column. So he has very cruelly not given us all possible circles because that would have helped us solve the puzzle. Not Phistomefel style. No, I'm joking. He's a brilliant constructor. He gives you enough to solve the puzzle. I don't think we've ever come across an unnecessary clue in a Phistomefel puzzle, not even a 6x6. You can correct me if I'm wrong on that if you want. But this isn't easy. I mean, that is a 6x6 puzzle that has taken me over half an hour, and goodness only knows, a 9x9 puzzle is not 1.5 times as big as a 6x6 because it is 81 cells compared to 36, so it is well over twice as big. The degrees of freedom are huge in comparison. I wish Simon every good luck if he attempts this live stream, and I will be joining in to watch it if that happens. But it is going to happen. I think he's said it's going to happen, and he said it's going to happen at 9 tomorrow. So we look forward to that. I hope you enjoyed this. I hope you had a go at it because it's an interesting... Well, I mean, this 6x6 would have been a perfectly good puzzle for the channel anyway. So very happy to put this out to our Patreons. Thank you for watching as always, and hope to see you again soon on the channel. Look forward to seeing you perhaps in the live stream with Simon tomorrow. Bye for now.